This is the second part of the linear and quadratic function section. Earlier we were talking about the different ways that you could look at a quadratic function and know if it shifted up, down, right, left, or if it's stretched, and all of that sort of thing. Well, here we're going to be focusing on the vertex form of a quadratic function. You remember standard form is ax squared plus bx plus c. Of course, that's in function notation. Well, remember that's standard form. Your vertex form is this one here. If you can get your function into this form, then you can automatically know what your vertex is. Your vertex will be hk. So just remember, whatever is inside here, the x coordinate of the vertex is opposite that number. Okay, so let's see if we can put this function into a vertex form. To do that, we're going to have to complete the square. Let me change my color, make sure you can see what I'm doing here. So we have f of x is equal to negative x squared minus 2x. I'm going to leave a little bit of space here, and then plus 8. Well, whenever you complete the square, you need to make sure that a, this value right here, is 1. Since it's not 1, we're going to have to factor that out. So we'll factor out a negative 1. That will leave us with x squared plus 2x. And we only want to factor that out of the very first two terms. Now to complete the square, we take half of b, so half of 2 is 1, and we square that. That means we get a 1. We add a 1 in here. So this 1 came from the fact that we took half of 2, and then we squared it. Half of 2 is 1, and 1 squared is 1. That's where this 1 came from. Now remember, if you add something into a function, to keep it from changing, you also have to subtract that thing. But you have to be really careful because we didn't add just a 1 here. We added this negative 1 times this 1. So what is negative 1 times 1? That's a negative 1. So really what we did was subtract 1. So to keep it all balanced and equal, we need to add 1 on the outside. If that didn't make a whole lot of sense, rewind it. I'm going to say it one more time. We take half of 2, which is 1, and square it, we get 1. If you add 1 in here, normally you would do minus 1 out here to keep it all balanced. However, we didn't just add this 1 because of this negative 1 out here. If you were to distribute this out, we would actually have added a negative 1 times 1. So we really added a negative 1. Well, the opposite of adding a negative 1 is adding a positive 1. So we need to keep everything balanced, which is the reason we do the opposite of it out here. Now, this parentheses will factor into a perfect square. It will factor into this all squared, plus 9. 8 plus 1 is 9. This is now in vertex form. You can see that if you look at your h and your k, remember the actual formula is x minus h, so that would be a negative 1. Minus negative is that positive right there. So your vertex would actually be negative 1, 9. Okay, we also want to find the x-intercepts. So how would we go about doing that? To find x-intercepts, remember you always let y equal 0. So if y is 0, we have 0 equals, we'll just use it in this form right here. Negative 1 times x plus 1 all squared plus 9. Alright, we can subtract 9 from both sides. We get negative 9 equals negative 1 times x minus 1 all squared. We can divide both sides by a negative 1, and we end up with 9 equals x minus 1 all squared. Now we can get rid of the square by taking the square root of both sides. When you do that, don't forget plus or minus. So we have plus or minus 3 equals x minus 1. If you add 1 to both sides, you get 1 plus or minus 3 equals x. I'm going to switch that around. X is equal to 1 plus 3 is 4, and 1 minus 3 is negative 2. So your x-intercepts will be They will be 4, 0, and negative 2, 0. Okay, we're going to transfer all of this information to the next page and then show you what the graph looks like. So our vertex was negative 1, 9. So here's negative 1, 9. There's the vertex. Our x-intercepts were negative 4, 0, and 2, 0. So we know that our parabola looks like this. Also, we can find the y-intercept. Do you remember how to find a y-intercept? Let's review that really fast. To do that, you let x equal 0. Well, if x is 0, then this is 0, and this is 0. And all you have left is this plus 8. That's how we come up with this 0, 8. And you can see here, this point is 0, 8. So you do have these nice little points that you can get from your parabola just by looking at the form of your function. You can get it by looking at the function in this form right here.